recording this, even though it's going to be kind of a little bit different. But I think later I'll also ask you about the use of, like, we've used a lot of Colab in class during this semester. I'm also curious about your feelings about that, but I'll save that for at the end of class. I have a question for you though. I ran a regression. I have a data set on drownings and ice cream sales. To start off class in sort of a morbid way, you'll like ice cream, right?
Yes, of course.
Have any of you been to Twisters in Bloomfield?
Oh yeah.
Nice, isn't it amazing?
It's amazing.
It's this. You can walk up to like the outside of a row house. It's a business, and there's like a window in the front, and you just like knock on the window. You ask for your order through the window. You pay through the window, and then they like hand you an ice cream cone. You're standing on the sidewalk, and they just hand you an ice cream cone on the sidewalk, and then you can just walk around. And if you're getting around by bus, you can take the 54 directly there. So the 54 just runs right through Oakland. You can just hop on, takes you just directly to Twisters. Amazing.
I mean, like everything in Bloomfield is a row house.
Yeah, exactly. Yeah, a row house or a church.
That's different.
Yeah, exactly. So so I have this data set on ice cream sales and drownings, I ran this regression. I have these two, this like mortality rate, which is drownings, and then I also have ice cream sales. So if you're in public health, this is the kind of thing we try to pay attention to. So it's like a variable that's related to how people are doing. And I ran this regression. So I have drownings, and then I have beta 0 plus beta 1 times ice cream plus the error term. And when I ran this regression, I got a positive coefficient on beta 1. So beta 1 was positive. And I got a very small p-value. So my p-value was less than 0.05, so very small. Part of the reason I like using slides is because my handwriting is horrendous, so apologies. My slides are also horrendous at times. But my question for you, what is this? Someone tell me what's going on here. I have a relationship between ice cream and drownings. Yeah, Corin.
Causation.
Yeah, so Corin is suggesting causation. Someone tell me the causal story. Why is this causal? Yeah. Okay, so maybe rebutting Corin's causal claim of a direct relationship. Maybe there's another variable. So let's say we have a third variable, which is an indicator of outside temperature. So we have temperature. Now does the story make sense? It turns out in the summer, more people go swimming. When the weather is nice, temperature is higher, people go swimming. Also, when the temperature is high, people like to eat ice cream from Twisters, among other places. And so during the summer, we see both an increase in ice cream consumption and an increase in swimming, leading to higher rates of drowning, something we're concerned with from a public health perspective. So both of these things go up during the summer, leading to a positive relationship between them. This beta 1, first off, does not indicate causation. Sorry to break it to you, Corey. First off, it doesn't indicate causation. It also does not indicate a direct relationship between the two variables. So we have these two variables simply because there's a positive beta 1 that's statistically significant, or like very unlikely to be due to chance. It does not indicate that there's a direct relationship between the variables. It does indicate, though, that there's some relationship between the variables. What we're doing today is building a model in a very simple way that sort of gets at this idea. It's what we call a directed acyclic graph. And you're going to correct my spelling on acyclic. But this is sort of our motivating example, and we're going to come back to this from time to time. So we have our three variables, and we're wondering how they're related. So to build up this motivating example, we need a couple extra components. So how many of you know any graph theory? Or have seen some graph theory before? Luke, of course, a little bit. Yeah, so you don't need to know a lot of graph theory to understand the basics. We have points, and then we have lines connecting the points. It's not a theory of like a scatter plot. It's a theory of networks, basically. So we have a couple building blocks for what we're doing today with relationships between variables. The first is we have what we call nodes. Which are basically just the variables themselves. So in this case, we have three nodes. These are the variables. So in this example, we have our three nodes, which are, we have drownings, we have ice cream, and we have sales. Excuse me, we have temperature. So those are our nodes. We also have edges, which are the connections between the nodes. So often you'll see like pictures of like social networks where you have a bunch of different people laid out with separate nodes, and then you have like the friendship connections between different nodes. These are what we call edges, which are just the connections. So edges, these are the relationships between the variables. So with our example here, someone tell me some of the edges we might expect. We have temperature, ice cream sales, and drownings. What are some edges? Yeah. Temperature and drowning. So more people tend to swim during the summer, which ends up leading to more drownings by accident. Yeah. People eat more ice cream in the summer. So we've already talked about these things. So we would connect temperature and ice cream together. So we have two edges. And I would say there's probably not a direct connection between drownings and ice cream. Maybe, so we could tell a story. Let's say, ice cream has a lot of sugar. Sugar makes you more energetic. It maybe makes you behave more impulsively. And so maybe when you're behaving more impulsively and you're swimming, then you make poor decisions. But I would say probably no direct connection. Okay, and then we have our arrows. This is the third building block. This is the direction of causality. Okay, so someone tell me the direction of causality in our graph here. So this is what we call a graph. Just a connection of edges and nodes.
Temperature to ice cream.
Okay, so temperature impacts drownings and impacts ice cream. So definitely, if I eat ice cream, that's not going to change the temperature outside. It'll change the temperature like in my throat, but that's about it. So the direction of causality moves in one direction, which isn't always going to be the case. All right, so we have our arrows, our directions of causality with our network. And in these kinds of graphs, what we call directed acyclic graphs. I'm not going to spell this out. Directed acyclic graphs. We have a couple of main kinds of structures. So I'm going to talk about 4 of them, and then we're going to run through 2 to 3 examples just to make this clear. Okay, so we have our main example is the simplest one. It's just a direct relationship. Direct relationship. And this is really just, we have, x, some variable x, is impacting just directly some other variable y. So I'm currently training for the Pittsburgh Marathon. The more miles I put in, the faster my marathon pace will be, assuming I don't get injured. So there's a direct relationship between miles run in training and how fast I run the marathon. So a direct relationship. We also have 2 direct relationships here. Temperature leads to higher ice cream sales, just directly. But we also have some other structures. So this is the simplest one. We also have indirect. Sometimes what we call a mediated effect. So this is, we have some intermediate variable that's mediating the effect of x on y. So this is, the way we write this is x impacts z, some intermediate variable z, which then impacts y. So as an example here, you all study for your classes. You put in the time, some of you, to prepare for the classes. A question we might wonder about is whether the time that you prepare, so your study time, does that impact your earnings later? So like when you leave college, how much money do you make? And I would suggest, I don't have the evidence for this, I would suggest that there's an indirect effect. That the more time you study, the higher your income, but that the effect is indirect. And it's indirect through things like your grades. So the more you study, the higher your grades. And then the higher your grades, the better your job will be, or something along those lines. There are sort of indirect sort of like skills that you learn, which are indicated with your grades. Lots of indirect variables impacting your income. So the model would be something like this. We have study hours. And then we have, so this is our x variable. We have things like grades and skills. So the more time you put in studying economic data analysis, the better your skills are for analyzing economic data. And the better your grade will be in the class, which will then translate into the kinds of jobs, like your performance in your job, which then leads to your income and so on. So there's sort of an indirect effect. These grades and skills, this z variable, is what we call a mediator. So we sort of mediate the effect of study hours on income through something in the middle. Okay, so this is what we call an indirect effect. We also have 2 more. So unfortunately, I'm running out of board space. If you don't mind, I'm going to erase the example. So we have another one which is a common cause, which is the example we have on the board. Common cause, which is that x and y are both impacted by some z variable. So this looks like this. So z is impacted by both x and y. Can you see in the back? Is my handwriting large enough? Okay. So this is the same model as this, right? We have some z variable, which is summer temperature, which is impacting both of our x and our y. So both x and y are being impacted by this third variable, z. Then the last one is what we call a collider. Which is sort of the opposite, where we have both x and y impacting our z variable. Maybe a classic example here might be, so if you're an athlete in high school, that could lead to you being admitted to a college just on your athletics. If you're a good student in high school, that could also lead to you being admitted to college on your academics. So college admissions is impacted both by being an athlete and by being a good student. So this is a collider. Both things are impacting the same z variable. Okay, so this is how we sort of set up these kinds of structures of correlation and causation. We've added some additional level of structure to our network by including arrows, which are directions of causality. Sometimes, and we're going to actually talk about some of these, one of these examples, but sometimes we don't have clear ideas of which direction the arrow is going. So there might be like two directions of causality, and those are a little bit more complicated. Often we can still deal with those problems, but in general we think of these DAGs as having one direction of arrow. So what this allows us to do is write down in a very clear way the assumptions that we take into our modeling. So writing down and communicating the assumptions can allow us to do something extra on top of the statistics that we're doing. So let's run through some examples. I have 3 prepared, but I expect we'll probably only get through 2. And what we're going to do is try to use these DAGs to help us think through the regression model that we're actually going to run. All right, so before we do that, are there any questions? So nice. So we'll call this example 0. And then let's start with example 1. So one question we might have is higher income directly related to better health? So these two things, do they have a direct relationship on each other? So is there an arrow between them? So the question, is there a direct effect of between income and health? And let's say we have 3 variables. So we have income, we have some measure of health, and we have education. So the first thing we're going to do, and I recommend you do this when you set up your final project, is to actually write down the causal graph. So the ways you'd expect these relationships to play out. So let's just write these out. We'll fill in the pieces together, and then we're going to write down a regression equation based on the directed acyclic graph. So we have income, we have education, and we have health. What are some connections, and what would we expect about the directions of causality? So if you're more educated, you're more likely to make money. And what would we expect about the arrow here? So a direct causal relationship from education on income. Yeah. Yeah, there is some evidence showing that this is true. Yeah. What else? What are some other expectations we might have about the relationships between these variables? So if you make more, you might be healthier. So are we saying the arrow would go towards health? Okay. And why would this be?
Professional athletes can put more money into maintaining their body because they make more money.
Yeah. Notable example, like Derrick Henry he spends so much money on his physical health. And yeah, so we can be healthier because he's just spending a ton of money. We live in a country where, unfortunately, you have to you can buy better health if you if you have more money, you can have access to better healthcare outcomes. We're trying to change that, but that's the way it is currently. What else? Is this everything?
I feel like health would also increase income, so health would point to income as well, because you need to be healthy to make money.
Okay, so maybe we also have a second direction of causality. So it's easier to do your job when you're healthy. Yeah, that can definitely be true. What else?
More educated people will make healthy decisions for their bodies.
Okay, so if you're more educated, you may have you may be better informed about your health. Okay. Anything else we're missing?
If you have more money, you're going to be able to get a better education.
Yeah, so this is another one. We also know that the more money you have, the better your education tends to be. So there's also a direction of causality going in this direction. So we have a lot going on here. What we can do with these models is clarify the assumptions that we bring into our modeling. This is a notable example in that it's very difficult to disentangle each of these pieces. What we're going to talk through is how we would set up a regression equation to try to target our main question, which is there a direct effect between income and health? So this is our question. We're not going to be able to establish whether there's a causal link. This is too complicated for us to be able to do that. But what we can do is try to think through whether there's a direct effect, whether these are actually directly related, and the strength of those things. Let me give you an example why this is important to think about in our research. Let's say there was no direct effect between income and health. And we could still see a relationship between income and health simply through the effect on education. If higher income is correlated with higher education, and higher education is correlated with better health, then just like with drownings and ice cream, we can see an indirect effect between an indirect relationship between income and health, even if there wasn't a direct relationship. So if we were to run a regression simply using income and health, but there was no effect, no direct relationship between the two variables, we could still get a positive coefficient. So let me just write this down, and then we're going to think about how we would fix this problem, how we would try to establish a direct relationship between the two. So let's say we try to predict health using beta 0 plus beta 1 times income plus our error term. Our null hypothesis in this case is that there's no relationship between the two variables, no direct relationship. But if we were to run this regression, if there was no relationship, we could still get an indirect relationship, just like we did with drownings and ice cream. In establishing a direct relationship between income and health, we want to compare two people with the same educational level and compare differences in income and health, right? We want to compare two people who have the same education, but with differences in health and income. This would allow us to make the correct comparisons. How many of you remember how we would compare two people with the same education? Like, how would we adjust our regression equation to make that comparison? We hold education constant. How do we include that in our regression model? Let's take a second. I think you all like talking to each other. So give the person next to you a compliment and then tell them how you might recommend fixing this regression equation. How would we hold education constant?
I'm assuming he's in the military.
Yes. Yeah. Definitely.
Okay. So let's say, well, does anyone have an answer for me? How do we control for another variable?
Would you add another data and then multiply the whatever you're trying to hold on to?
Okay.
So the education on there.
So let's rewrite this. So we have health is equal to beta 0 plus, and then you're saying include this. So beta 1 times income. And then what else would we include?
Beta 2 times parentheses income times education.
So income times education. Any suggestions about this? This is provisional. Don't put this in your notes just yet. Any suggestions for how to fix this? Only wrong answers at this point. Luke.
I have a question. So you said that the education remains constant between the two people?
Right, so we want to compare two people who have the same educational level and compare their income and health. So it's like we're only going to look at the same people, or the same, we look at the people with the same level of education. So what I'm going to do, I have one small fix here, which is to actually pull out income. So all we're going to do is include a third variable, education. And what we're doing here is essentially including a fixed effect or a vertical intercept for each level of education. Just we're controlling for a third factor, which means once we've pulled out education, we now have only the direct effect of income on health. And so what happens when we do this is we actually eliminate all of the indirect effect of income on health through education. This allows us to control just for the direct effect. So what this does is it knocks out that path. If we were to include summer in this regression, we would get no effect of income, ice cream consumption on drownings. Okay, and the basic idea is just as I've said it. When we include a control variable, what we're doing is comparing two individuals with the same level of education, which allows us to rule out the possibility that differences in health are due to something coming through education. So it's not going to be due to variation in education. So this control variable allows us to establish just this direct effect. All right, so this is the first example. We're going to work through a second one. And you're going to put in more of the details as we go through it. Okay, so our second example is, I've actually already put it on the board earlier. But let's say we have three variables. We have high school academics, we have high school athletics, and then we have college admissions. And we're wondering if there's a relationship between high school athletics and high school academics. So are your grades in high school related to your athletic performance? It's always dangerous to put your personal marker on the shared whiteboard marker holder. All right, so example 2. So the question we're gonna try to ask is there a direct relationship between high school athletics and high school academics? This is one of the reasons slides are better, is because I can write them out instantly. Between grades and athletes. And so we have three variables. One is grades. Second is athlete. And the third is college admissions. So the first thing we're going to do when we see this data is try to build a directed acyclic graph of this. So let's just put up all three. So our first one is grades. Second is athlete. And then the third is admissions. So when we're thinking through these relationships, what are some of the possible connections we could write out?
Grades to admissions.
So grades to admissions, yeah. So nice. So higher grades would lead to a higher chance of being accepted to a college. Yep. And what's another one? We've already talked about a second one. Yeah.
Athlete to admissions.
Athlete to admissions, yeah. And probably a direct causal arrow going from your athletic performance to being admitted. And what's our question? What's the question at hand? Luke?
Whether or not there's inherent in grades to athlete.
Yeah, so is there a direct relationship here? And you'll notice that we haven't framed the question itself in causal language. We're just talking about, is there some connection here? We can maybe make assumptions about which direction the arrow would go. It might be that, you know, if you're more motivated, just overall, you're going to do better in school and in athletics. But maybe there are other, you know, stories going on here. Maybe like more time practicing means less time studying. So there could be a negative relationship. But a positive relationship would also make sense if you're just generally more motivated to do all of the things. So this is a question. So question for you. We're going to take about a minute here. I actually want you to try to write down a regression equation to answer our question. We have three variables. We have our directed acyclic graph, which tells us visually the expectations for the directions of causality. And then I want you to think about how we can use the different variables to try to get at the question at hand. Like, what's the right regression to write down? So take about a minute here. Tell someone you're something fun you're going to do this week, and then talk through a model. Okay, someone help me out here. Wrong answers only. What I'm going to write down next, I'm hoping will be wrong. What's an idea?
I have grades is equal to beta 0 plus beta 1 times athletes plus beta 2 times athletes plus the
what was after this?
Plus beta 2 times administration.
And then plus the error term. Correctly incorrect. This is not the right model. Someone tell me why this is not the correct model. So what we did here is we controlled for education, which meant that we were comparing two people with the same level of education, which is exactly what we wanted. We wanted, two people with the same level of education, so we didn't see a direct effect of education on health. So we knocked out this arrow of causality, of education on health, which is what we wanted. So what we're doing here, by including admission into college, is comparing two students who are now in college. Some of those students will be selected on their academic performance. Some of them will be selected on their athletic performance. So we have this selection. You've been selected based on some criteria, which is criteria either athlete or grades. So we're picking those who have higher athletics and higher grades. And what this means is some students may not be very good in either one of the categories, but will be selected for admission on one of them. So if you're a good student, but not a very good athlete, you can still get into college. And if you're a good athlete, but not a good student, you can also get into college. So we have sort of a selection effect. And by including this, we're controlling for something that's being impacted by both of these effects. So including this leads to a selection problem. Any questions about this? When we have colliders, including the z variable introduces problems. Where when we have something like this, which is sort of more complicated, but it's sort of more like an indirect effect or a common cause, including z as a control variable reduces problems. So someone tell me another model we could write down. Luke.
Would we just ditch the beta 2 and administration thing?
So just knock it out. So let's just knock this out. This is how I would run this model. It's a pretty simple question, it turns out. All we're going to look at college, high school students and whether they're good students are good athletes. But once we introduce admission into college, we're actually adding complexity, which can lead to confounds. So it's like, it actually introduces some extra problems. So you could see, in theory, a negative relationship between athletics and grades for those who have been accepted into college, simply because we're selecting on an additional variable. Or we're selecting on both of the variables at the same time. Okay, any questions here? So moral of the story, when we have colliders, including the z variable actually introduces problems, or in most cases, basically all other cases, including the z variable actually fixes some of the problem. Okay, and you can sort of think about this like, we want the relationship between these two variables, but these two aren't impacting each other through admissions. They're just, they're both impacting admissions. Okay, Y'all want to do a third example? My last two classes, we didn't get this far. So I'm excited to do a third example. So we're going to ask a similar kind of question. Is education directly related to higher savings? So when you hit retirement, do you have more money if you have more education? So this is sort of going to feel pretty similar to some of the questions we've already started to answer. Maybe a little bit more core economics. Actually, let's do that again. So example 3. Is education directly related to higher retirement savings? So we're going to have 3 variables. We're going to have education, we're going to have income, and we're going to have retirement savings. So what I want you to do is set up the DAG with someone next to you. So write down the causal relationships you'd expect, and then we're going to build one together on the board. And then from there, we're going to build up the regression equation. So we'll take about a minute here. Tell the person next to you your favorite color. Okay. Someone help me out here. What are some possible directed relationships? Also, whose favorite color is blue? Nice. That's the only correct answer. So for the sake of time, maybe I will not ask you these questions unless someone wants to fully answer this. Yeah, Luke. So bidirection between education and income. So yeah, we Frank's correction earlier, and then we have the thing that we also know. So we definitely know higher education leads to higher income, but we also know higher income leads to higher education. Both of these ways. Yeah. And what else?
So like if you have higher income, then that'll lead to more savings.
Okay.
And since education and income is bidirectional, then we can also see that education,
you're talking about this connection? Okay. So, let me clarify one thing. So we do know that because we have this this mediator, higher education leads to higher income, which leads to higher savings.
Then we don't need that.
We know that there's an indirect effect. Our question is whether there is a direct effect. So this is the question. Even though we do know, as you're pointing out, that there's an indirect effect. Yeah. So how would we write down a regression equation to capture not the indirect effect, but just the direct effect? Luke again.
So would it be savings equals beta 0 plus beta 1 times education plus the error term?
Plus beta 1 times, you said education?
Yes.
Plus the error term.
Yes.
Someone want to make a correction to this?
Would we also include income as well?
We would include income. We want to compare two people with the same level of income, but with different levels of education. And we want to see if education directly impacts or is related to savings. And by controlling for income, because this is a mediator, by controlling for income, we can eliminate this indirect path. We're controlling for this effect of income on savings. Right? If we run just a regression of income predicting savings, we would get the indirect effect. So by including beta 2 in our regression equation, we're comparing two people with the same level of income but different levels of education, and we're comparing their savings. Okay, any questions here? So you can see we have this direct arrow from income to savings, and what we're doing by including that in the regression is we're knocking out this path, which gives us our beta 1. Okay, so I think we'll leave it here. If you have questions about the final project, so some of you submitted that you wanted to work in groups, but you didn't have partners in mind. I'm going to try to match you with partners this week, and I'll get that information out to you. I'm going to post the next homework, which will be due a week from now, which will be more of an extension on the final project. So you'll have a little bit more framework to start making some progress. And then I'll post more information about the office hours on Friday, which you can come drop in and chat.